Okay, so I have solved all four problems. So let's quickly go through them. The first one is okay, so we are given two timestamps in this format, hours, minutes, second, and you have to tell the number of seconds, like the difference between the start and end time. So, okay, so we like this is like a simple implementation idea. Just fetch out this hour time first. So like since this is given as a string, so you can just check the index 0 and 1 and they strictly follow the format. So we just check index 0 and 1. So index 0 multiplied by 10 plus 1, and this minus 0 is like the minus character 0. Like because like if we fetch this, like if we have this format, then start of 0 will come as 48, which is equal to character 0 as key code. So we will do this minus, so we will do start of 0 minus 0 like this. So start 0 minus 10 plus start 1, sorry, into 10. So this will give us the h1, and similarly h2 will be from end, and then we do h2 minus h1 times 3600. So that is like the number of seconds between them. And since it is given n times not earlier than start time, so we can clearly guarantee that this answer is always positive. Similarly, so 0 and 1 index were for hours and minutes, 3 and 4 in sorry 0 and 1 index was for hour, 3 and 4 index was for minutes, and 6 and 7 index were for seconds. So same idea we will do for m1 and m2. Here m1 can be greater than m2, but in that case also we are subtracting the answer, which is the correct idea. So like let's say if you are at 159 to 2, so what we will do, we will technically do plus 1 hour minus 59 minutes. So we will get at 1 minute eventually. So doing this operation is also fine. I hope that makes sense. Okay. And then just return the answer out, taking the sum of hour, minutes and seconds after converting each into second. Okay, so first one. Second one, okay, here we are given an array and we are given integer k. So we start with k resources, and every time we can ask for k more resources. And the first time we ask, the cost is 1, then the cost is 2, and so on. So and we have to like process each element, and for that we need nums of I resources for ith element, and after processing that available resource decrease by nums of I. So if we just see it in a different way, it is just like the sum of the elements nums of I. We just have to process them all together because it won't really make a difference if we process them one by one or process them all together. It's just like this will be subtracted, other, or if this is greater then we will increase k. So like if s is the sum, so we will do s minus k, these many we require more, and each time we get k, so the number of operations we will do is ceil of s minus k by k. One second. Okay, yeah. So where were we? S minus k by k, ceil. This is like the number of operations, or like the number of times we are asking, we are increasing the value. So the cost will be 1 plus 2 plus 3 plus so on till ops, which is obviously ops into ops plus 1, 1 by 2. So this is like mostly the idea. Uh, but here we have to care about the constraints. I actually got one penalty because of this. If nums of length is 10 power 5, nums of I each is 10 power 9, then s will be 10 power 14. Now if k is 1, then the number of operations will be 10 power 14 as well. So doing ops into ops plus 1 by 2, that will actually overflow even long. So we need a bigger data type than that. So I have used a 128-bit integer, but I guess doing mod here as works as well. But then you cannot do divide by 2 simply. You need the modular inverse of 2. But yeah, that is still a simple idea. So yeah, I hope that makes sense. Uh, so moving to the third problem. This one, okay, so let's go to the problem first. We are given integers m, n, and k. So we have to create an m cross n grid filled with free cells and obstacle cell such that we start with the top left cell, go right or down, and we have to end at bottom right cell. And the number of ways to do that is exactly k. So like if we see this example, there's one path this and one path this. So there are two ways to reach this end from the start. And similarly here there are four paths like this. Here like in 1 cross 4 grid there's no way to reach achieve k equal to 2, so we return empty one. Now the I mean this is like simple backtracking idea. Let me just show it here. So I start with n and m. Like I personally prefer n cross m, so I swap the order. Here in problem statement is m and n. But yeah, I swapped them. Then uh like this is like a simple backtracking idea only. We are given the grid and dp, and then we like this is the solve function which will do the backtracking for us. So I've just checked, like currently I made it return an option of the grid. If it returns the grid, good. Otherwise, we will just return the empty vector. So going through the grid. So like if we are at the end and like there's a standard DP idea for this one. The number of ways in which you can like you can choose in a path to get from top left to bottom right, the number of valid paths. So that is the idea I've used here. So I've maintained a dp as the number of ways to reach from top left to bottom right to that cell ij. As you can see here, dp is n cross m. So dpij is number of ways to reach from 0 0 to I ij, grid ij. So if we are at the end and dp of n minus 1 m minus 1, this is basically that is equal to k, which is what we wanted. So we return the grid. Otherwise, we don't have it yet. And then we process the grid accordingly. First, we choose the cell as a free one. Then we choose the cell as the obstacle one. If we don't find answer in either of the cases, then we return none. Otherwise, we return the answer when we found it. Now, I mean, this solution is easy to understand, but honestly, I don't know about the time complexity of this because, like, in worst case scenario, what I think is M and like this is a 10 cross 10 grid. So, for each cell, if we choose two options, so it is like 2 power 100 of possible combinations. So, that will definitely not fit in the time complexity. But case 4 here, so I thought that maybe the grid will we will find a grid early if it exists. So I thought that doing the free option first and doing the obstacle option later will work. But I am honestly not sure if it will work always, or like what is the exact time complexity of this. Like if we do this, yeah, it gave us the answer, but again I'm still not sure like what is the exact time complexity for this. But yeah, that's problem third from my side. Problem fourth. Okay, so here we are given a grid. We have to remove some columns such that The in the remaining grid, the adjacent in the adjacent columns, each each row has a maximum absolute difference of the limit given. One second. Okay, yeah. So, like in this first example, we just have one row. So this is like minus 2, 0, 3, and limit is 2. So currently their difference is 2, their difference is 3. So if we remove this cell, then we will have all the rows with difference within the limit, like the absolute difference. So that is so this is like a good. So the maximum columns we can retain. The minimum columns we will remove. That is the answer. So here we can retain maximum two columns. So two is the answer here. So like just see the next example as well. In this it is 2, 2, 2, 1 minus 1, 1. So in this the limit is 1. So here if you see the differences is like 2 and 0. For the second row it is 0. And here also the difference is 2 and 0. But the limit is 1. So if we remove the middle column, then we can get the difference here as 0 and 0, which is within the limit of 1. So we here also answer is 2. Now how I've solved it is like the constraints are like 250. So mine is like a n square uh, yeah nm square solution, like rows into number of columns square, rows into column square. So first of all, I checked for each column if they are within their limits. Like if if we choose both of them as adjacent, will it work for them? So like I've created this variable in limit, which is and like a m cross m. Like m is the number of columns in my case, as I mentioned before. So I iterate over all possible pairs of columns, and then I check if they are in their limits, like the difference between them is within the limit. So I check for each row if they like if and just checking like if the absolute difference is greater than limit, then we will set as false. Initially it was true. Okay, then it was a DP idea. So what I've done is DP of J I have taken, like the jth column. So it is the maximum number of columns. So max columns we can take such that we take column J. We take column J. If we take column J, then what is the maximum number of columns we can take from 0 to J? Maximum columns in 0 to J. If we take column J, always. So this is my DP. So the way I have done it is like to find DP of 0 or DP of J. So DP of J is always going to be 1 because we can take the jth column and remove everything. That will always be within the limit. Otherwise, I check over all columns from 0 to J, 0 to less than J this is. So if J and J2 are in limit, then we set DP of J as DP of J2 plus 1. So this is the transition idea. Because then this is like if this was a grid and J is here and let's say J2 is here. And if these two are like if these two are within their limits, within this limit, then we can remove everything in between. There may be multiple columns. We can remove them and just merge them. So the maximum we could have taken till J2 here, maybe this would have been a part of answer. This is there. Then we take this. So that is one possible answer we have. So we check that in a transition. And then The maximum answer is going to be like the maximum value in the DP. It will not be DP of m minus 1 because we need not necessarily take the last column. So we iterate over DP and just find the max value. It is like the max of DP of J for all J. So yeah, that is idea for problem 4. So that's it from my side. Thanks for watching. Bye.